we would like to train something. Das Epson. Is Epson also Chinese or Japanese? Epson. It's not Korean.
Yeah, not Korean. Japanese.
What?
Japanese.
Japanese. The picture from Mr. Aras was better than mine. Yeah. Methods for design of symmetrical reactances. There are several possibilities. And what can we do? We spoke about additional reactor. Yeah? And the first maybe on transformer connection. Yeah. We can also add a reactor on electrode arm. What can we more do? What is more? What possibilities we have more?
What if more added electric?
I will show you.
Phase B is more higher.
The middle phase we put
phase.
higher.
Yeah.
This is our old system. Yeah. Now we make this clamp on electrode 1 meter higher. We can do that here. Head of electrode here, yeah?
Yeah. Oh, this is just really
No, we must do that in general data. Here. Yeah?
Yeah.
1 meter higher. Okay? We will have a look, and you see the system is suddenly symmetric.
Yeah.
Yeah? Very good symmetry.
Yeah.
I trained this before. Yeah, we have look into the controlling picture. You see, this is, we call this the triangulated system, yeah? See, there's also a picture in it. This was state of the art. You see, in the middle phase, the tubes are in triangle to the outside phases. They are higher. You see that also here. Yeah. This is a possibility. This was state of the art. It came from America. Electromelt. This picture is from about 1970.
Yeah.
You see?
In this case, I think some problem.
The other problems are there. What problems do you have?
In this case, electrode length.
Here,
Length,
you have 1
yeah.
meter
Yeah,
more or
yeah,
less.
yeah.
Losses.
Yeah.
Most of the loss resistance of a high current system is in the electrodes.
Yeah.
Here are many, and this is not good. Also, you need the electrode moving system, the hydraulic system.
Yeah.
Must be 1 meter longer.
Yeah, that's right.
And if you make a construction, mechanical construction, this system should be as stiff as possible. Make this stiff, not weak. If this system is weak, the electrodes begin to oscillate. And this also, there are problems. There are problems, but we are not ready. There are more possibilities. I will show you another example. I do that back to 0.
No. General data.
This is wrong.
Yeah.
General data. I will show you another. Nobody is thinking about. You have seen there on that map that this is a low and this is a higher reactance. If we could give this a smaller diameter, then I'll see for diameter in phase B smaller, so that you get this or this. We can show this, for example, here in the middle phase, to 2, I take 1. You see, in the flexible cable, this is in the middle phase higher than in the outside phases. Yeah, this is this. We can also choose 2, and this is much better than before. Yeah, this is possible, but I think this does not help. We need also enough capacity for current. This does not help. Yeah, but we can do something similar. We reduce the distance. Yeah, from 250 to 125. The distance is phase B. Yeah, horizontal distance. We will write 125. Yeah. What happens? It's also better.
Yeah.
See that?
Yeah.
It's very good. Yeah. If we reduce. Now we have what have we done? In the outside phases we have this. And in the middle phase we have done this. Yeah? These are also possibilities, but number 4 is not so practically. Yeah? It's not so practically. You can take this and make the distance older for this. Yeah? And let them contact them. Make distance older. You can do that. But it is not so practical. I think this was the state of the art. About 1970. And additional reactor came together with from and later. There's also the possibility of this system. I showed this before. This was the first one. Yeah? This is smaller than this. It's a little bit height, triangulated a little bit. But this was the first connection of Asma-Stier by Fuchs. But this also has, very stable, has a little disadvantage. You know what? Disadvantage? We have, Alice and I have calculated this by hand. Disadvantage? This is welded.
Yeah.
And if you have oscillation, this construction can break. Yeah, you know everything what can happen will happen on the furnace. You know this before. Okay. Now you see here a triangulated system with aluminium electrode holder. This is in the middle phase. You see, but we must have a longer hydraulic system. Okay? Example. I'll write it out. First, lay out from Fuchs. Asthma. What we have in the middle phase. Phase B, yeah? Well, there are many possibilities, and you as a constructor, you can decide what is better for you. I want to speak with you especially about the first three. Yeah? Okay. Number 4.
I have a question.
Yeah?
In this case,
Yeah.
I think this additional reactor is loss power is increased. No?
No, I don't think so. Yeah, you can calculate, but it is, you can calculate the loss power if you have a construction, but I think we have done this. I will put that back. Oh, we have snow again. Let's have fire with model data from second. Drawing picture. This is the first.
Yes.
The first attempt. You can calculate
Yeah.
the loss power. You know the kappa
Yeah.
surface, the kappa area. You can calculate this
Yeah.
from here to here and to here,
Yeah.
but when you make a measurement,
Yeah.
you have different results. I tried this, but it does not help. Yeah, you can calculate this, but in reality, the loss resistance is higher. This is not important. The most part of loss resistance is in the graphite of the electrode. This is the first one, and there's a little. There's a little idea we always calculated with these reactors with 4 sides, which are 1 meter, about 1 meter long.
Yeah.
You have this is 0.558 million.
Yeah.
This is for 50 cycles per second. 50 cycles.
50 seconds.
If you have a 60 cycles per second, it's 20% higher.
Yeah.
Yeah? You have 60 cycles per second.
Yeah. 60.
We have 50.
Yeah.
Now you know, if we have a reactor of this size, and this is 1 meter, the additional reactance is about 0.5556 million.
Yeah.
And this is nearly the same value of the reactance difference of the electrode arms. And I think you should not make these things longer than 1 meter. I would say maximum 1 meter, not more, because this thing can also make own mechanical oscillations. If you have special forces from the current, it began to oscillate. And everything what is done here is getting bad. We may have a look. This is the system. Yeah, it's a tube of 120 millimeter diameter and 10 millimeter thickness,
Yes.
and the current is flowing inside, and here
Yeah.
are the flexible cables connected. Yeah.
Yeah.
You can also have another picture, this picture here. This is also a transformer connection. You see that? And this is a special one because this is a delta connection. Yeah? And they put the transformer connection. This is a poor kappa, I think. And put that higher, and do not put this transformer connection onto the wall here. You should not put that because the magnetic field is going through the wall, and if you have steel in the wall, the steel is heated. And the wall is beginning to get hot. Yeah? This is a good construction. You see, this is a double shaft furnace. These are shaft, scrap for scrap, and they have, I think, 2 bottoms, and this can change from this to this. I think this is this construction of Luxembourg. I do not know if they use this preheating scrap system. Yeah, I don't know that. You see here the water-cooled panels. But you see the advantage. Oh, you see how the cables are connected. See that here? The flexible cables? Yeah, you see that?
Yeah.
This is a smaller part of the electrode arm, and they are connected as I showed you. Okay? Is that important for you, yeah? This is very important. I'm not allowed to give you the pictures. Okay. But you should learn something. Okay. The reactor also can happen on the electrode holder. Sometimes you do not have enough space if you do not have enough space on this side, you can add the reactor at the end of the electrode holder. Yeah.
The other case, we can see this diagram.
Yeah. You want to know the reason for this? We have this example later. Yeah. I will show you. I think. This I have made new, and this looks so. You see that? We have a look from the top. You see that?
Yeah.
And we may have a look from the side. This is. You will ask me, why do they make this?
Yeah.
You know the reason? I do not know, but I think if the clamp, if the electrode is small, the length is small, maybe here's the roof. About here's the roof of the furnace, and they do that because this part of the electrode holder should be get a higher distance from the roof, from the hot roof. I think this is more. The reason would be to hold these things. Get more distance from the roof. This may be the reason. I do not know the other reason. The other reason may be yes, you can see here. Here's the roof, and they want to have this. Maybe they do not have enough space, therefore. They must do that because here's the end. And therefore they can get with this part to the top of the roof.
Yeah.
This may be the reason, yeah? Yeah. Okay. And there is another possibility to make the same reactor on the electron arm. On the electron arm. And many of the construction look like this. Yeah? This is a construction of the electrode arm. You see, here again is the connection of the cables. You see that? They are connected to the start of the reactor. And here between is in isolation, because on this part the reactor is connected to the holder. The current is flowing in this direction. So, yeah, and you know, this has a big advantage because you do not need to weld here in this. You can fix it with.
Fixed the port.
Yeah? Okay. Well, this is a typical connection. You see, there's a small distance. Small distance to the cable of the middle phase. And many of them are built are made so. But this is 1.2 meter and this is 1.4 meter. This is the highest value I would choose. Okay? Is that, these are the possibilities to connect this at the end of the electrode holder. Well, this was done very often by the company of Fuchs, which does not exist. And now I would like to discuss with you the questions: can we use a reactor with two windings? You know that? What I mean?
Two windings.
Two windings. There's one winding.
Yeah. And the transformer side and.
Yeah, on this side especially, on the electrode. Can we use a system with two windings?
Two windings.
Yeah.
One winding
therefore.
and then.
No,
This one.
two windings. I mean, the system.
Ah.
This is an idea for me. No one has made this before, but it can have many advantages. Yeah?
What kind of this?
What?
What is it? What's this?
Yeah. I will show you. Our program with our program, the Elektronenarm reactor. No? No conductor? Elektronenarm reactor. Yeah. With our program, you have 8 fields. You can give data in 8 fields here.
Yeah.
You use only 4,
Yeah.
but you have 4 more,
For
and you can make a construction. Yeah? Shall I show you a construction? You see? These are 8. 1, 2, 3, 4, 5, 6, 7, 8.
Yeah.
And I've made one for this seminar. System has 2 windings. 5, 7, 8. You see that in the 3-dimensional? Yeah?
Yeah.
2 windings. And we see that this looks. We start here. 2, 3, 4, 5, 6, 7, 8. You see that? One tube of 80 millimeters. The reactor is 0.8 millions. And they are only long, maximum 500 millimeters. Half. Half. The material is the same.
Yeah.
The material is the same. When you get 0.8 millions,
Yeah.
isn't it a present for you?
Is this no problem?
What?
Is this no problem? Is in this case, this is no problem?
I did not understand.
And in this case, we can apply this data,
Yeah?
and we apply it in project.
In the project.
Yeah.
No,
This is
but
problem.
this is an idea.
Yeah, your own
Your
idea.
idea, scientific idea, and this much smaller, 500 millimeters, so more. I will give you more information. You know, many furnaces have an additional reactor on the primary side of the furnace transformer. Yeah? If there's not enough electrical stability, yeah. Many furnaces have also this Hamburg steel plant. There's an additional reactor which is built in the transformer box. And this is a typical electrical plan of steel. Arc, high current system, the furnace transformer. Many systems have an additional reactor.
Yeah, that's right.
This only has reason to increase this reactor of the high current system because this is too low. And you can also add a reactor not only in the middle phase, you can also add reactor in phase A and phase C with 2 windings especially, and then you do not need this. Yeah, the only disadvantage of this reactor is you cannot switch it off. Yeah?
That's right.
That's right, yeah? You cannot switch it off. It's to all times, this many reactors you can switch on load. And I will discuss this with you. You see, the result is very good. And therefore, I make this idea, gives this idea, a reactor can also have two windings. A two windings reactor with 0.5 millimeter has a reactance of 0.8 milliohm. Two windings. Can have advantages. You must only weld these edges, yes? But it is not so big. Yeah? It's much higher. Therefore I made another paper many years ago which can show the reactance of 1, 2, 3 windings. You see, the system has
1988?
this 1988. You're laughing. I was so old as you today.
Yeah.
To this. And this is my idea. This is a tube of 150 millimeters diameter and thickness of 50 millimeter, and the lengths are half a meter, 0.7 meter, and 1 meter. You know, this of 1 meter here has with one winding 0.6 milliohms. This is your reactance. But if you use a two windings reactor, you get the same reactance with a length of 0.5 meter. But you can also use a three windings reactance. You get more than 1 milliohms with three windings. Yeah? And I have also written how many microohms you get with 1 kilogram of material, copper. That's about 5 microohm per kilogram copper. Yeah? And you see, if you use this construction, like this, with one or this, you get 2 milliohms more, and you do not need a reactor on the front side. You can receive a lot of money. What do you think about this idea?
Very good. I think it's very good.
But you must have the decision to make this. If you have a great company who makes 3 or 4 furnaces a year, you can test it.
We are going to in some bio plants. For example, 15 ton per charging. So we can use the added primary side. Primary side we added a reactor. And what is test and the bio plants? So we click primary side to insert the reactor. Cannot cancel, and we can use this
instead of the reactor. The additional reactor on the primary side costs a lot of money.
Right.
The advantage of this vector would be on the primary side, if you can switch it on node. This is a good advantage.
Yes.
Yeah? Okay, this is my idea for you. You can have this. Why I have from these special designs, I have the files. You can get this from tomorrow. There's a stake, yes?
Well, questions. In this case, we use the distance of this gap.
Yeah. You see how much I make this distance, and I don't know how much distance is. Or we start with 160 millimeter in this. In this direction, and then we go 500 millimeter to the top. Yeah, this is 0, yeah, and then this minus 450, 0 plus, so this is set. And then we go to this, to 50, plus 50. This distance is already 500 millimeter, and we are going down. There's a displacement of minus 100. This is the displacement. Yeah? And the thickness is 80 millimeter. This must work. This must work. Now we see. Yeah. And here's a displacement in this direction of minus epsilon minus 100, and then we go down, and this distance may be 100 millimeter, and the diameter is 40 millimeter, and the gap is 20 millimeter. 20 millimeter. Okay? Yeah? Oh, but this is your decision, what to do with this. Yeah? Or we started on this. 1, 2, 3, 4, 5, 6, 7, 8. Here's the end. And here's the start. Okay, this is a two-winding reactor. This is an idea for me. I do not know if anybody has made a construction of this.
Yeah.
Most of the people who make these constructions hesitate to do this. Yeah, they will not are angry to lose their jobs. But it's dependent from your company if you want to do this or not. It's an idea for me. Okay. I intended to discuss with you all these possibilities. Reactor with two windings. There's also possibility to make a formula for this.
아니, 그러니까 투와인딩 말씀하시는 거죠 지금? 예,
병렬.
병렬
분열이 아니고 분열.
이 상태 말씀하시는 거예요.
두 개.
이렇게 이어지도록
두 개.
두 개를 이렇게 와인딩을 해서 하는 거예요? 표본성으로는 아니에요?
이렇게 두 개. 케이블러로 두 개. 반대로 부스 연결해.
이거 이렇게 말씀하시는 거예요? 이렇게 해서 그 프로그램에서 안 되는 예.
When I was a young boy, I made calculation of this
Location.
before we had this program. This from 87. You see, this is in a reactor with two windings. You see, the reactance is X self reactance plus 8 times. Yeah? And then you must have the coupling from this to 5. Positive or negative? Positive, because the current direction is the same. Minus 1 to 3, minus 1 to 7, because the current direction is different. Plus 5 to 1, minus 5 to 3, minus 5 to 7. And then you must go from step to step and calculate the reactances itself and mutual reactances of the system. You get this equation. It's a long equation. These programs must faster, and did this. You see that 500 millimeter, and this was the result. 8 times the same. It was 50 millimeters distance. See, and the diameter was 225, and the result was 0.568 ohm. Is 50 centimeters, and this is what we have calculated here. Yeah, this is a simple solution of this. Yeah. I made this, and this is, but nobody has made a realization of this. But you can do that if you have a furnace which needs to every time additional reactor. You can use this construction.
You can change the parallel addition, parallel to parallel reactor addition.
Yeah? You can do that. I think there's no danger in this. You must keep that together, these parts. You must make a whole here. Yeah? And if you make 1, 2, I will take number 3, 5, 3. Yes. You see also this in this picture what I've seen before, I've shown you before. You see that here? The only one you must make an isolation is in this part. this point must be isolated from the electrode holder because the current is flowing in this direction. And you can calculate how much is the voltage on this reactor. The voltage may be 60 kiloampere multiplied with 0.6 milliohm. This is going back. It's 36 volts. The voltage is very small on this because you do not should be afraid that you get arcing here. No. Arcing can happen on this side, this isolator. Yeah? You can get arcing. Here must be an isolation. You know, yeah? Okay? Okay. Okay. Okay, this is, what number is it? 5. 4. 5.
Yes, 5.
The two windings reactor can have advantages. You are thinking about this. Yeah.
The other case.
About this equation, or are you tired? Shall we make a stop? Okay, the two windings reactor. That's my idea.
Yes, thank you.
If you are making this, you can send me a picture and a postcard. Okay?
Yeah.
This is my point number C. Yeah. Now, we have about 1 hour. An hour. Let's make a little stop.